Why are so many battery startups failing? Does our world need more chemistries or more batteries? And why should you manufacture in the US? For a Take Charge First, I'm joined by a father and son combo, Johnnie and Taylor Stoker, who are co-founders of Ultion Technologies located in Las Vegas, Nevada. Johnnie is the CEO who founded and grew K2 Energy to become a leader in the LFP space. During his successful 18-year tenure, with plenty of those spent in China, he learned invaluable lessons and recently identified a huge opportunity to focus on an American-made solution. To answer my previous questions, we talk about horizontal versus vertical integration, the EV gold rush versus other applications, misalignment between revenue and production, dry process, and much more. It was a real honor to be joined by Johnnie and Taylor, and I'm excited to see what the future holds for Ultion Tech. So, let's take charge. Taylor, Johnnie, welcome to the show. Thanks for coming on.
It's a pleasure to be here with you, Jamie. Thanks.
Great. Well, from left to right on my screen, obviously we've got Johnnie and Taylor. The first time we've had father and son on the podcast, so that's a real pleasure. And I'm intrigued to learn about your backgrounds and Ultion Tech as a business, and we're going to talk about a few topics today. So before we get into things, let's start with your backgrounds. Johnnie, I'll let you go first.
Great, thanks. Yeah, I'm a PhD chemical engineer. Worked in the chemical industry initially, mostly around materials, material processing. I had the interesting opportunities as I developed in chemical engineering, to be both operator, technician, scientist, engineer, and then transitioned in 2001 into the battery industry with Valence Technology. Actually set up Valence's operations in China, ran that as VP of China operations, and then in 2006 set up and founded with a group of associates K2 Energy, and ran that until a few years ago, where we then split off the technology for building cells and started Ultion Technologies.
Brilliant.
Yeah, and
And
I'll,
John,
I'll jump in and give you my background. So I followed this guy around, all over the world building batteries for the first part of my life, and batteries have always been the end game because of that. And so early in my career, when I graduated college, I got into the tech world and started in software to really see what is the new age kind of growth strategies and ways of operating and using technology for efficiency. And really, what I started to see was the speed and the efficiency when it came to cost management and whatnot could be applied into other industries. And so, in conversations with Johnnie, we saw all of these issues happening with battery companies that we knew how to avoid. We had strategies that we had learned in different businesses or different careers, and we wanted to apply those and make our dream come true of building batteries here in the United States.
nice. Well, let's start with K2 Energy. First of all, kind of honing a little bit on your experience there. Talk us through K2, because it wasn't long ago that you kind of parted ways with that business.
Yeah, so we founded K2 with three goals in mind, and those were number one, to have the highest energy density lithium iron phosphate batteries on the market. Number two, to make it profitable, and that ties into the theme of what we're talking about today. Is certainly a battery company has to be profitable eventually, or why are we in the battery business? And then third, to build cells in the United States. And at the time, it was clear there was going to be a lot of cell manufacturing in China. But eventually, I knew it would rotate back and we would be building cells in the US. And that time has come. And so that was the main reason for the split off from K2, to focus on cell and pack manufacturing in the US.
Very good. And then you mentioned there, obviously, the US is making some big movements in terms of manufacturing in the US. Of course, the pace is slow, but the future does look good. Las Vegas is where you're based, a good location. So yeah, why Las Vegas? I know there's a big push for manufacturing there, and what is the benefit to manufacturing cells and packs there?
Yeah, so first thing I'd touch on is we've been building batteries here in Vegas for over 20 years now. And so that's really the first aspect of why we made our choice to base it here in Las Vegas is this is home for us. We have a strong network, strong government ties. A lot of our suppliers are based out of here. And so we should have a strong network. So that would probably be priority number one. The other reason too, though, why 20 years ago we even decided to start building them here in Las Vegas is a lot of it has to do with the climate. A really dry climate is ideal for cell production. It lowers our costs, internally for energy and things like that, but it also affects the performance and the quality of the battery. And so, dry climate being another big aspect. The other, area, and you're seeing a lot of this with the Tesla Elon Musk discussion right now of, Las Vegas and Nevada is really friendly to startups. It's kind of like the new Delaware for filing your LLC and whatnot. And so very, cost structure is very friendly to startups and for companies like ours, like Ultion. And then the other aspect is the availability of key materials. There's a lot of, mining and refining that's being done up in Reno. And so we just see Nevada is growing and, very soon to be big hub for battery manufacturing. Is there anything you'd want to?
No, that's we've talked to people many times about maybe moving somewhere else, and yeah, we there are some advantages here and there, but you really have the critical mass here in Las Vegas and Nevada in general. So there's really no good reason to move.
Of course, so no selfish reasons. So in terms of personal interest and things like that, it's all for the business.
Yeah, I mean, it's hard to have selfish reasons when it's over 100 degrees in the summer. So, yeah, definitely business reasons.
Well, and Jamie, I've drug my family all over the world, quite honestly, for work. So I'll go where the job needs us to go. There are really good reasons for being here,
Nice.
business wise.
Yeah, definitely. Good stuff. One of the topics we're going to discuss today is why. Well, we're going to talk about dry process. You mentioned dry process there before, Taylor, but let's get into the kind of core of the conversation, which is why so many battery startups fail, even when things initially look quite promising. What's kind of your assessment on this?
Yeah, so one of the ways that I like to look at the industry is let's look at what's gone really well versus what hasn't gone well. And the reason I like to do that is most hasn't gone well. There's a lot of startups that have failed along the way as, over the last 2 years or 2 decades. And so with what's gone well, it's gone well in China, right? And we saw that firsthand by being over there in the early days of lithium ion. And so one of the things that China has done, these Chinese manufacturers have done really well is rather than horizontally integrating, they're vertically integrating. And so they really own their stack of the supply chain rather than trying to, make versus buy every aspect of the supply chain. And so that's kind of, area number one that we are focusing on is if your customer wants to buy a battery, then you need to be able to supply the cells, be able to do the design, the prototyping, the testing, and building the packs and manufacturing them. Right now in the United States, that's non-existent. It's very, very fragmented. It's very, people are trying to horizontally integrate their one product. And a great example of that being EV, right? You typically see one EV company or one maker has one battery company that they work with, and that battery company is trying to horizontally integrate it. And so that's one area that we see a major problem here in the United States that we know we can solve.
Yeah, and Jamie, I'd add to that when you look at battery companies that have failed, and we could talk about several if you want to go into any of those details, but I like to sum it up this way. Um, innovation is what are we going to build? What are we going to do? Ingenuity is how we're going to do it. It's more process focused. And my background in the chemical industry, taught me a lot, and a lot of our team, about the what. I mean, we know what we need to do, but how do you do it? And we've proven successfully several times now, getting Valence up and running and commercializing the first lithium iron phosphate, setting up operations in China and operating there successfully. And then at K2, developing the highest energy density LFP battery, becoming profitable. Really the last piece, which now I think the climate is right, is now let's do it in America and build the cells here. And we have the ingenuity, the process, and the know how to do the what.
And I think it's good to give you an exact example of where we see this happening. Let's use EV as an example. So there is kind of this gold rush mindset right now with EV, where yeah, it is a massive market. It's growing really, really rapidly, and there's a lot of incentives tied to it. But if you look at innovation, right, we know we want to increase the range, or we want to, improve the safety, or let's focus on range, right, of the EV battery. And if you want to do that, right, you need to go all the way down to the cell and improve your cell technology. What we're seeing a lot of the industry do is you either see incremental, not real improvements, or you see science experiments that are just pure innovation plays. And so a good example being a cathode producer. Someone may, start upstream manufacturing with refining the LFP material, and then they want to move upstream, farther downstream, sorry, into producing cells. And so they're like, okay, well, let's start with cathode production. And when they start producing cathodes, they're going to have to sell those to a cell manufacturer, and they're going to have to integrate it into the cell. So there's an assumption right there that's just wrong, where improved cathode is going to always improve, your cell. In reality, it's how the cathode, the anode, the separator, and the electrolyte all play together. So ingenuity comes in and saying, okay, we are experts in every step of this process, and we can bring it together to actually build the innovation that the market needs, that these applications need. And so with that, going back to that EV example, it's really hard to do when you have multiple companies you're working with trying to bring ingenuity together so that their innovation works. And then when it doesn't work, you have a very undiversified customer base, meaning both companies suffer. There's one supplier, one customer. If their demand goes down, everything kind of just starts to crumble. And we see that across the industry with, lots of different situations happening.
Interesting, because the more I'm learning about the industry and spending time in the industry, I can see many solutions, whether that's keeping everything in house in the US, or outsourcing, or manufacturing in China, or whatever it might be. But I'm also seeing blockers, and something that you and I discussed before, Taylor, was the misalignment between sales, generating revenue, and production velocity. Actually getting there, if you have lots of suppliers, everyone being on the same page, having enough runway to make it happen and become commercial. What have your kind of observations been on this?
Yeah, so this is something I saw happen a lot in my experience in software before, jumping back into the hardware industry, seeing this a lot as well. And so one of the kind of concept that we talk about in startups in this aspect is the startup valley of death, right? And so the first, phase of that, and there's an interesting graphic. If you've never seen it, I'd definitely look it up. But as you first start out, you're bootstrapping, right? You're using your own money or someone else's, like an angel, family, and friends' money to kind of get your idea going. And then you get your first institutional investment, and it's off to the races. And in software, that's where you start to see that really, hockey stick exponential curve in growth. In batteries, though, it's almost like you need a couple phases of that to get going, unless you have a head start on your ideation process or your ideation phase. So let's, look at some examples once again from people who have done this successfully. I think the two biggest examples being CATL in China and also BYD in China. And what's interesting about them is when they started off, rather than their idea of requiring 5 to 7 years of funding to, do these science experiments in reality and try to bring the innovation to the market, they already had commercially viable, products that they could be selling, revenue streams. So as they're generating the production, the velocity with sales, their production is not tied to, really, really high amounts of funding to actually do the development. And so the examples with CATL, how they did this was they were a spin-off actually of ATL. And so they had, a decently mature portfolio of products. And then on the BYD case, they were using secondary batteries that they were repurposing. They didn't start necessarily as a, car manufacturer. They started as a battery company. And so we see that as examples of what market leaders need to be doing. And here in the US, that just hasn't been done. And so that's really, what we see is as we're ramping up our sales, our production is ramping up, and we need to make sure that those are aligned. And then,
Yeah, no, that's all spot on, Taylor. And um, uh, the main thing I would add is that when you look at EV as a market and talk to the customers or potential customers, the number one thing they say to startups or small companies is come back when you grow up. Prove that you really have a product and are sustainable. You look at who they work with. They work with these really huge battery companies from Asia that have been around for years, and what we're saying is, okay, let's build that foundation Taylor just talked about. And at some point, if it makes sense, we can foray with a major EV company into that market. But the market is so huge, and we have the right products for these specialty niche. These are huge niches. That's what's funny about using that term. But there's so many opportunities there where we are differentiated and innovative and can provide solutions better than others.
I think the final comment I'd put on this is if you've ever seen the Tesla pyramid go to market model, the first phase, what Tesla did was, the Roadster, right? A very niche product for a very specific type of customer. And then they went, to I believe the Model 3, the Model Y, and then, so on, right? And really what that looks like as a business is going after the small specialty niche areas that are low volume, that match our current production capacity and our plans to ramp up, but high margin, right? This is high levels of customization, really high performance batteries, typically that require a much higher power output than something like an EV or, energy storage system would require, meaning it needs a higher performance cell technology, which is what we have.
Great. Um, we touched on dry process before. We've had guests on before. AM Battery's been one of them, talking about dry process and the history of Maxwell and the acquisition from Tesla. And I was getting quite excited about what this means for accessibility of talent, particularly in the US versus wet process, because there just aren't as many professions that can transition into battery manufacturing versus dry process. So I was getting quite excited about this. And then when we were talking before, it sounds like it's been around for a while. You guys have been doing it for many years, which is great to see. And of course, that lends itself nicely to Nevada, Las Vegas.
Yeah, so something I'd like to touch on here, this is a great example of, one process won't fit them all, right? Your process on producing a cell is going to be different even from company to company, from cell to cell. It depends on the performance characteristics that you're trying to achieve with it. Once again, what kind of innovation does your ingenuity need to bring to it? And so with dry process, that's something that one of our other co-founders, John, he's been building batteries for about 30 years. When I was talking to him about dry process and AM batteries, he was like, "Oh yeah, I've actually been doing that since 1999." And so it has been around. There's different ways of doing it. We do both dry, wet processes. Really, our process is more of a novel process. But it's definitely, there's been technologies around similar to dry process, actually a lot of other technologies, and it's highlighting the cyclical aspect of the industry. If someone didn't have the right ingenuity to bring their innovation to the market 10 years ago, it's almost like, hey, let's recycle that innovation and maybe we can figure it out this time. I think the real way of validating true technology in batteries is, once again, is the end product, is the consumer product. Who is building the batteries that meet the expectations of who is buying them? And how they get it done is going to be unique and different from cell to cell and manufacturer to manufacturer.
Yeah, and when you look at implementing any of these new processes, whether it be the dry process, solid state, other new materials, there are so many engineering problems that have to be solved. I think it's been made public, at the Gigafactory in Austin, where they're implementing dry process from the Maxwell technology. Uh, they're having issues with yield, with temperature control, and I could get into more details, at least rumors that you see or hear or grapevine. But the bottom line is you've got a lot of problems to solve. Just by its very nature, the dry process is not a good mixing process. Wet process is much better, much easier to follow. So you're going to have to deal with those issues, those potential problems. Well, how do I get the right mixing? How do I get the right distribution of the materials that I need throughout the electrode, throughout the battery? And so those are not easy problems to solve, obviously, because if anybody throws a lot of money at problems, it's Tesla, and they've shown a lot of ingenuity in the past. So I give them a lot of credit for what they attempt to do. But in the end, it's got to work and it's got to be cost effective. And so is the time right for that? I mean, we'll see over the coming, years, but really these ideas have been around for at least 20 to 30 years. And we've worked on them directly, we've been involved in them, and we will implement them as the right technologies come together and as we solve some of these problems.
I guess we're talking hot topics and trends. Um, we see a lot of them. Does the battery industry have a tendency to jump on these trends too much, looking at the kind of next generation of chemistry or slightly different type of cathode, rather than actually focusing on quantity and looking at existing methods and equipment?
Yeah, so this is something that really got me very interested in jumping back into batteries a few years ago. Was there were a lot of these discussions around things like solid state, LMFP, stuff that honestly I'd heard Johnny throw around the dinner table almost my whole life, right? And so I was very curious on where has this myth of one battery to rule them all, for lack of better words, come from? And so some of these examples, like I was mentioning, solid state, this is something that's been being worked on for 30 years and is still not a commercially viable solution. And so, other things like LMFP, there's some actual aspects of it that I think a lot of the industry that is not from the technical side just doesn't quite understand. So with the LMFP example, the manganese does extend your capacity and your range, but only for a period of time before it dissolves. And then after that, you now have a battery that's going to have a lot of issues. And so there's all these different, hot topics. And I think what it comes down to is it's not one battery to rule them all. It's batteries enable new markets and new technologies. A good example being an EV toll, right? That's a really cool, exciting, futuristic technology that has a huge potential to, add value to everyday people's lives. But right now, the batteries that we're focusing on for EVs don't have the power capabilities needed to lift the EV toll off and then operate it and then set it back down. And so, they're really, what we see is we need more batteries and better batteries that actually are built to solve real problems in the market rather than, hey, we potentially can, make it a little bit better, or this, if we ever figure it out, will make battery production a lot more cost effective or the performance better. It's more so what problems do we have in the market right now and how can we solve those with batteries?
Yeah, I would add that, and sorry, a little bit about background, but as I left Valence and started K2, part of the reason I did it was because of this reason, this idea that, oh, we're always chasing the next bright and shiny thing. We're always going after innovation. And I'm like, what I saw in lithium iron phosphate was, here is a battery chemistry that fits a lot of needs that are being served right now by other types of batteries not very well, whether it was lead acid or nickel metal hydride or nickel cadmium. And it opened up a lot of new applications. So I saw a bright future in LFP batteries. So we started K2 and really emphasized that. That said, even in my own sales team at K2, I had to convince them, look, guys, there is not, how'd you put it, Taylor? There's
One
not
battery.
one battery for all. Even, lead acid, how many different kinds of lead acid battery are there? Size, shapes, types, power, energy, deep cycle, glass mat, and on and on. And so the point being, there is a lot of customization. And that's what we're really good at. And let's do that with the advantages of LFP: low cost, high power, long life, the best safety of the lithium ion family. And so we're continuing to advance those boundaries and serve the markets where it fits the best.
And really, going back to the, different, innovations that everyone keeps focusing on or jumping onto, the way we see it is there's new technologies, new markets, new applications, and these are going to require innovation, right? But there's also these existing markets and existing application lines that a lot of people just overlook because they're looking at that new shiny next best thing. We like to use mature materials that have gone through a lot of product development, are doing really well in new innovative ways, bringing them together to meet those application needs. And once again, looking back on China, China didn't go straight into EV, and they're not necessarily completely focused on EV with their battery market. They're looking at buildings and industry is what they've kind of coined it as, which is things like forklifts, robotics, different applications that are currently running on lead acid batteries can be switched out with lithium ion. And we see it as, let's use the best material for the widest variety of applications that's mature, and let's innovate on the design so that we can push the performance of it as well, and then look to the new age as we continue to ramp up production.
Nice. You've been talking a lot about different chemistries, different applications. You mentioned before about kind of vertically and horizontally integrated processes. I've spoken to previous guests around, is it best to focus on a niche topic? Have just a certain type of cathode material or electrolyte component or whatever it might be. Do you just focus on cell or pack? I understand you guys do both cell and pack, so making it difficult, I guess, or maybe easier if you're going to prove me wrong. So, talk me through kind of why you do this and take this approach?
Yeah, so we are firm believers on, and this is something I don't see in the industry much, and it was very, very big in software, but we are firm believers that customers come first. What they need and what they want is what we are trying to, one, develop, and two, produce and deliver to them. And so the first thing that comes to mind is when a customer is looking into, and when I say a customer, I'm thinking of our target markets, these specialty markets, not necessarily the EV mass market. And so when they're developing their product, right? Let's say a medical device producer. Typically, what we see is the last thing that they take care of in their design and development phase is the battery. And oftentimes, people make the assumption that the battery is like an off-the-shelf, commodity component that they can just buy and drop it in and it works, right? And that's just not the case. And so when they get to the battery, what happens is they go to a pack integrator. That pack integrator doesn't have any technology. They don't have any know-how. They just have a network and connections typically. So in reality, when the customer wants to buy a battery to serve a certain function, they have to design it through the pack integrator, which generally is going to involve about 3 to 5 companies. A designer, someone to test and prototype it, a manufacturing partner, cell selection, cell partners, all those different companies that are involved in it. So what this does is the customer is having to pay a much higher price because of all the different margin shrink that you have throughout that stack. And the time that they're waiting is 1 to 2 years just to get a working prototype. Where if they come to Ultion, they give us a power profile. What is the power output, or how is the power used by your device, by your application? Great. Within a month, they will have a working prototype. And what it also allows is the margin shrink, getting rid of that. So if you look at power walls right now on the market, Teslas are going for like 13,000, and that's pretty much like the benchmark. 10 to 13,000 is what we've been seeing. To be frank, that seems absurd to me, and it's because it's going from, there's a cell producer, someone designing it and prototyping it, then there's the pack assembly, then the pack integrator, all these different steps that just everyone's trying to protect their margin, and no one actually cares about that end customer. And so that's a perfect example of what most people are doing is horizontally integrating, and we're vertically integrating. And the reason we do that is, once again, customer wants to buy a battery and they want it to meet certain performance specs. By coming to Ultion, we can deliver that battery.
Nice. Perfectly put. You've convinced me.
Glad to hear it.
And you mentioned before as well about the EV gold rush, and maybe organizations being a little bit blinded by this and kind of jumping on that rush. There are so many different applications. You mentioned there: medical, drone, eVTOL, military. Talk us through your applications and where you see the potential for Ultion.
Yeah, so final energy demand right now in the world, only about 20% of it has been electrified. So about 80% of it is still out there to be electrified. And that's where EV is just if you think about transportation, it's just a small aspect of final energy demand. And so, other applications that require things like batteries are solar, right? There's solar lights, LED lights, there's energy storage for homes, commercial, residential, all kinds of different segments. And then also military. We are a dual use manufacturer. And so with a lot of the geopolitical tensions going on right now, all the different trade tensions, things like that, it makes sense to have domestic manufacturing here in the US. And so we also are focused on military applications. What we see when we say specialty, we're rather than defining it just as a market segment, we kind of like to define it as industrials. And the way we like to think about it is these are low volume, high margin products or applications, ones that there are not readily available off the shelf solutions for them. Really, that's kind of the opposite of what EV is. What we see EV as is in that Tesla, pyramid, the first one being the specialty markets and the last one being mass markets like EV, because they're high volume and low margin. What the industry, a lot, and when I say industry, I want to highlight this is really the investors, right, in the industry. A lot of them have been burned. A lot of them have, told us the phrase, "You're not considered a climate VC until you've lost money on a battery investment," right? And where those things come from are going after EV first. This high volume and low margin business, you're going to get stuck in the startup valley of death. And really, until you have 5-10 gigawatt hours of ramped up cell production, you're just really not going to make a dent, and you're going to keep getting that feedback from the automakers. Grow up a little bit and then come back and talk to us.
Nice, very good. So
Yeah, if I may, Jamie, real
Yep.
quick, just wanted to add that when we talk about low volume, higher margin too, it's amazing to me how many times we go out and bid a project and we are so much lower than these, let's say, horizontally integrated companies because we're one-stop shop and the customer's like, what? That's so reasonable. And, we're making money, they can make money. It's a viable model. Whereas if you just charge so much to do a prototype, how can it proceed? And so it really is a model that's worked, and it'll work better as we grow.
Nice. I assume as well that one of your application areas will be EV. It's just a case that you're not focusing on it.
It's as we ramp up our production, as we build, more manufacturing capacity, as we get to that 5 gigawatt hour to 10 gigawatt hour time, um, area, then that's when we'd be interested in going full force into it. But really, we're focused more on those specialty applications. The one that I'm personally really excited about is satellite and aerospace, and some of these newer technologies. I probably have that because of my younger age, but yeah. So there's a lot of different applications out there. There's the old school ones like lead acid replacements, just as simple as that, all the way up to batteries that are going up into space.
And
Right.
how we're going to do that, Jamie, is the not just innovation, it's the ingenuity and how to build electrodes and cells. And look at, and I won't name any companies, but look at the companies out there saying, oh, well, we're reinventing how you build a battery. So just the dry process is another way to build a battery. But what about the battery design, the components, the shape, the size? It's pouch, prismatic, and cylindrical. Well, are there any other new types, inventions or variations of those that could create a new and better battery for certain applications? And you will see, over the next few years, some new cells come out of Ultion that will address some of these new emerging markets.
You you mentioned before, Taylor, satellite and aerospace as areas that are particularly interesting for you. Um, and Johnny, you mentioned before kind of the bids that you go for. The customers are surprised at the value. Um, how are you able to achieve? Well, I guess of course being vertically integrated answers that question. But in terms of satellite and aerospace specifically, how does your technology, how does your chemistries, how do your packs give you that advantage in those markets?
Yeah, so right now the trend in well, first off, the statistic I want to highlight is that about 95% of announced battery capacity is tied to automakers here in the US right now. So what that means is the R&D, the investment money is all going towards batteries that are optimized for that power profile, EV and energy storage systems. Now those profiles don't require high pulse discharges or high peak power output. And so what that means is the R&D is they're looking at larger cell sizes and just trying to increase capacity, right? Like those are the two main focuses that they have right now. What that does to these other applications like satellite and aerospace is as the cell gets larger, the harder it is to customize it into this available space that they have, right? You can only do so much with a cylindrical cell that's, the size of some of these newer ones Tesla's coming out with. And so as that happens, there's also an aspect of as the cell gets larger, there's going to be more internal resistance, which also lowers your ability to deliver power. And so with the satellite and aerospace applications, a lot of them need a long continuous power, but they have a solar panel, attached to them, and they can constantly be charging and discharging. So the capacity may not be the most important, but they do have antennas and different radars and things like that attached to these that need to fire, have a really, really high power output for just a few seconds, right? It needs to fire the antenna so that it sends down the radio waves that then come back up that they collect. And so they need a battery that can, one, handle the temperature range of space, and two, also have the power needed to drive actually deliver the radio waves that they're planning on. And so there's a lot of different situations just like that where they need it to be more customizable and they need higher power. And that really is our forte, is high energy density with a higher power output than anything else in the market.
And while we're focused on, because we're really good at it, I don't think there's anybody in the industry that has more experience with LFP than our team. But we are looking at and implementing tweaks, different materials, different electrolytes, and we will develop some new cells or even just niche cells for specialty applications using our know-how, our equipment, and serve that market where, hey, we only need 100,000 of these a year. Well, if you can afford at least to pay for it, and again, at a value price, we're not talking about 3 or 4 times a market price, then we can serve that niche.
Brilliant. You mentioned before you're focused on being American made, and that was one of the reasons you parted ways with K2, identifying the opportunity in the US. Just, I guess, expand a little bit on that in terms of what inspired you to dedicate all your resources to the US and what advantage that gives you versus Chinese manufacturing.
Yeah, so this is an interesting topic. If you look back to, the World War time frames, really American manufacturing was a critical component that allowed our economy to flourish and still, produce. And right now, about 80% of our economy is based on services. So that was something years ago. That was one of the first things that really sparked my interest in getting into battery manufacturing was, how is our economy propped up by 80% of it's propped up by services? That's something that doesn't actually have true hard value. We live in a physical world. We want tangible products. And so that's one big aspect of it. The other, advantages and disadvantages is why globalization happened, you know, decades ago was because China was so much more cost effective. Typically what we see, they're about 30% lower in costs, right? The, labor and all the different things that go into it. And what we're seeing now is there's a great opportunity in the US. One, we need to reshore this technology. We need to have access to it regardless of the world stage situation. Our economy is built on these kinds of things. And so with reshoring it, the advantages and disadvantages, how do you handle those? And really with the IRA and other incentives out there right now, what they're designed to do is lower our costs as manufacturers by approximately 30%, making us cost competitive with China, but still having that US mindset on a higher quality or better performing technology. And so that's where, we really see a huge opportunity right now in the US is with these incentives, being able to compete with the Chinese manufacturers across the board, but also deliver better products without, all the headaches of logistics and, lead times and all that.
Yeah, and to just add a little bit to that, I think it's so important that America is, and this goes back to the innovation versus ingenuity. We need people that know how to implement solutions, that know how to solve problems. Maybe it's the scientist versus the engineer discussion, and we've lost a lot of that. It is concerning to me when I look at how hard it is to find young people that are ready to get their hands dirty, understand a process. And if we don't have that, we're not going to solve these problems that need to be solved. We're going to rely on somebody else to do it. And so, our goal has always been build this in the US. We had to go to China because everybody was going to China, and there was no way to fund building a battery factory 20 years ago in the US. But now there is, and we see the strategic need. And so we're just happy and proud to be here helping make it happen.
Great. I guess one of the challenges and something that I see often is availability of or access to talent in the US based talent who understands battery chemistries, and a lot of that talent is still coming from China and Korea. And a lot of my clients will ask me to find somebody who has that background because they ultimately have come from a CATL, Samsung SDI, LG Chem, SK On. But it's getting better. I'm seeing more and more US-based talent have the understanding of not just the research and development side, the battery chemistry, but also the process development and scaling pilot lines. So Sure, it's a young industry from a manufacturing perspective in the US, but I think we're going in the right direction with not just the technology, accessibility to materials, government funding, but then eventually talent as well should come with that. So, good luck with your trajectory and in terms of building that. Um, to help summarize, what does the battery industry need right now? Does it need, or what does the world need right now? More chemistries and better chemistries, or more batteries?
I would say batteries that solve problems, right? It's, we could sit in a lab all day and we'd probably have fun doing it, building all different kinds of cells that have different performance characteristics and whatnot. I think the way I would look at it is what applications would be better if they had a battery, right? Or what applications are limited without a battery? And let's build the batteries that meet those specs, right? And that is going to require more batteries and different chemistries, but we have so much available right now. Once again, the final energy demand has only been about 20% electrified. And so really I think we need to start focusing rather on batteries in the battery market, more so on what solutions do batteries provide adjacent markets and new markets that could be using that.
Great. And I really appreciate you both coming onto the show today. It sounds like exciting times, and obviously with your backgrounds, you're in a really good position to achieve success with Ultion. What are your goals, and what does the future look like for you guys?
Yeah, so our goals right now, we're in a fundraising cycle. So we are raising capital to expand our pack production. So we already have a commercial scale pack line right now that we're going to expand into multiple pack lines over the course of the next 12 months. And then we're going to start building out our first cell factory here in the US. And so right now we're focusing on meeting the needs of our current customers and preparing to expand our production operations.
Very good. And that will, of course, all be built within Las Vegas or Nevada.
Yeah, the initial phase, our plan right now is here in Las Vegas. We'll have an R&D facility, which we've already set up, and that's where we're building our packs right now. And then also a 1 gigawatt hour cell factory is the end goal for us here in Las Vegas. But we'll end up building facilities in other states and other locations as well. But this is, first step is here.
Great. Very good. To finish off as a closing tradition, you can either answer this as a collective or individually. It's up to you, because I'd be interested to see if you have the same or different answers. Johnny, with your tenure in the industry and your experiences in the past, and then Taylor, also relatively new to the industry. Where do we think the battery world will be in 10 years? How will it look? And maybe let's make it specific to the US.
Yeah, we will certainly see a lot more batteries made in the US. But honestly, I don't see a lot of like world changing innovations that are going to be different. We'll see more factories. They'll be cleaner than they've been in the past. They'll be more efficient. There will be better recycling technologies. Will be, you know, utilizing the cycle of materials better than we have in the past. There will be incremental process improvements, but I don't see it looking a lot different than it does today, other than in terms of volume and incremental improvements.
The way I see it is very similar to Johnny in the sense of the industry. I don't see changing much, but as we get better as an industry on focusing on the right products, the way I see the next 10 years is more from the consumer perspective, which is a more mobile, more electrified world. The thing that keeps popping in my head is we have a battery in our pockets, on our wrists, in our cars every single day, and that's going to become a lot more prevalent. You're going to see batteries used in applications more and more that allow us as people to be a little bit more mobile, not as tied to the grid and things like that. And that's really where, what I find the most interesting about batteries is it allows for so much freedom, so much independence. And that's something that as the battery industry focuses on the right problems and the right solutions, you're going to see that happening a lot more, a much more mobile generation because of it.
Nice. Yeah, two interesting perspectives. The kind of chemistry, what's available on the market, maybe not that different, but where we're seeing it in terms of applications and how we're consuming batteries, where it's integrated, huge changes. We've seen those changes in the last 10 years. So
Yeah,
that's
you bet.
a good sign, I guess, for anybody in the industry who's trying to sell these, because there's going to be there's going to be a lot of buyers. So, guys, really appreciate you coming on the show today. A lot of really good insight. Good luck for the upcoming fundraising round and expanding the business. It sounds like an exciting vertically integrated solution that you've got there. So yeah, thank you again and good luck.
Thanks, Jamie. Appreciate it.
Thanks. Have a good day or evening in your case.
Thank you. Cheers.
See ya.